students, welcome back. Let's continue with our TCP over ad hoc wireless network protocols. So far we have seen about the end-to-end approach of the TCP over ad hoc wireless network protocols. Now coming to the next approach, that is a split approach. So in the split approach, the protocol that the wireless network protocol is a split TCP. So now let's see this. What is the split TCP? Here the name itself is saying that we are splitting the TCP protocol. We are making two, means it's just a splitting of the TCP connections. The major issue that affects the performance of the TCP over ad hoc wireless network is degradation of throughput with increasing path lengths. So when will be the degradation of throughput will be occurred in the ad hoc wireless network? Whenever the path length is increased, automatically the degradation is there in the throughput. So this can also lead to unfairness among TCP session. So where one session may obtain much higher throughput than other session. So because of this increasing the path length, there is a lead to unfairness among TCP sessions. So one session may obtain higher throughput than other sessions because of this increasing the path length. So to overcome these disadvantages, the split TCP provides a unique solutions to these problems by splitting the transport layer objectives into congestion control and end-to-end reliability. So to overcome the degradation of the throughput, the TCP transport layer is going to split the TCP protocol into two layers. One is the congestion control and another is the end-to-end reliability. So that's why we call it as a split TCP. So in addition, the split TCP splits a long TCP connection into a set of short concatenated TCP connections. So that you call it as a segments or a zones. So whenever there is a long TCP connection is there, it will be break down into short concatenated TCP connections. So each one you call it as a segment, or you can call it as a zones also. So with a number of selected intermediate nodes, that intermediate nodes you call it as a, so this TCP is connected with the help of one intermediate node and another TCP is connected with another, means it's just a segments. Each segment will be connected with the one intermediate node. That intermediate node you call it as a proxy node. Okay. So that intermediate node we call it as a proxy nodes. So as terminating packets, terminating points of these short connections. So see here the diagram. So here completely one TCP connection was there. From source is 1 is the source and 15 is the destination. So from 1 to 15 there is actually one TCP, a long TCP connection will be there. So this long TCP connection is splits into short concatenated TCP connection. So that we call it as a segments. So here these are the segments. From this node to this is one segment, another segment, another segment. Or else you call it as a zones. So these segments are connected with the proxy nodes. That you call it as an intermediate nodes. These are the proxy nodes. Okay. So just take in between this. These two will be connected. Here this is a proxy node and this is a proxy node. So here in this these are all different intermediate nodes. These intermediate nodes which are participating in the network for data transfer and acting as a short concatenated TCP connection, that nodes you call it as a proxy nodes. So here this dotted lines is the network layer and the data that flows with the solid line. So this is a TCP data flow and acknowledgement, and this represents the proxy nodes, and this is the end-to-end connections. So let me explain this diagram now. So in the diagram, the operation of the split TCP, where a 3-segment TCP connection exists between the source node 1 and the destination node 15. So in between the source and the destination, there are 3 TCP connection splits are there. There is 3 segments are there. Okay. So 1 segment, 2 segment and the 3 segment. So this is 1 segment, 2 segments, 3 segments. So here the proxy nodes receives the TCP packet, reads its contents, stores it in local buffer and sends an acknowledgement to the source with the previous proxy. So here what is it? Let's take this is the 4 is a proxy node here. Okay, what this 4 is doing? The proxy node receives the transmission packet, is receiving the transmission packet from the source, reads it, it is going to read that packet and stores in its local buffer. So this 4 is going to store that information in the local buffer and sends an acknowledgement. Okay, and it sends the acknowledgement to the source. It's just sending an acknowledgement to the source, storing the information and sending the acknowledgement. So this acknowledgement is called the local acknowledgement. So because it is in between the proxy node and the source node, the type of acknowledgement that this proxy is sending to the source, you call it as a local acknowledgement. Local acknowledgement. So here this acknowledgement is a local acknowledgement, does not guarantee end-to-end delivery. So there is another problem here. So whatever the local acknowledgement that is there, that is does not guarantee end-to-end delivery. So in the figure, node 1 initiate the TCP session to node 15 and 4 and 13 chosen as a proxy nodes. So 1 is initiating the connection and 15 is the destination and 4 and 13 are the proxy nodes. The number of proxy nodes is determined by the length of the path between the source and the destination node. So number of proxies depends upon the number of proxies. You can say the length of the TCP. So in the figure, the path between node 1 and 4, you call it as a first zone. So whatever I said, and in between 4 and 13 is the second zone, and 13 and 15 is the third zone. Total 3 segments are there. Coming to the advantages and disadvantages of the TCP, split TCP. Advantages are improved throughput fairness and lessened impact of mobility. And disadvantages are requires a modification to the TCP protocol. End-to-end connections handling of traditional TCP is going to be violated here. And the failure of the proxy nodes leads to throughput degradation. So because of the proxy nodes only, we are splitting the long TCP connection into short concatenated TCP connections. So if the failure of the proxy nodes, which leads to the throughput degradation. So this is about the split TCP, which is an split approach of TCP over ad hoc wireless network protocols. Thank you.